Welcome. This presentation is a practical methodology for anyone who wants to use Claude and Claude Code to build software, whether you are starting from a blank page or picking up an older project you care about. You do not need to be a professional developer to follow along. What you need is a web browser, some experience chatting with an AI assistant, and the willingness to try. We will not sell you on the tools, we will show you how to use them with discipline, so that the result is software you actually trust. Here is how we'll proceed. We start with context and way of working, the two tools, the iteration loop between them, and 6 good practices that will shape every project. We then instantiate that method in 2 scenarios. The first, building an application from scratch. The second, building from a preliminary or older version, which is a different beast. You have constraints the blank page doesn't give you. We close with key takeaways and common pitfalls. One note before we begin. A companion document summarizing all the recommendations in this presentation is available for download on the website linked at the end. If the method presented here suits you, you can hand that document to Claude at the start of your next conversation, and it will follow these recommendations throughout. This talk is for anyone with a need, a minimum of curiosity, and the desire to try. The prerequisites are genuinely light. If you can use a web browser, and if you have already had a conversation with an AI assistant, you have the foundation. You do not need to be a professional developer, and you do not need to know Python, Git, or testing frameworks in advance. Those tools will appear along the way, and Claude itself will help you learn them. What this talk adds is a way of working that keeps your project coherent over time. If you have never used Claude Code, you will leave knowing how to start. If you are already using it but feel your output drifts, you will find the practices here address exactly that. One point is important enough to raise before anything else. Granting Claude Code access to a folder on your computer is a significant decision, not a casual one. Once authorized, the agent can read, create, modify, and delete files in the folders you grant it. The same care applies to the chat. Anything you paste into the conversation leaves your control. Keep sensitive data, credentials, and critical files out of the folders the agent can reach, and out of what you send to the chat. Work in a dedicated, isolated project folder. The PDF and the companion document give concrete precautions. Treat this the way you would treat handing someone physical access to your workstation. Before we touch either scenario, we need a shared vocabulary. In this first section, we will distinguish the 2 tools, Claude, which you talk to in a chat, and Claude Code, which executes in your terminal, and explain why you want both, not one. We will describe the iteration loop between you, Claude, and Claude Code. And we will lay out 6 good practices that recur in every project: a specific folder layout, a small test case built early, a clean separation between tool and runs, a development history folder, pauses between blocks of work, and disciplined management of the Claude discussion itself. These practices are not optional details. They are what keeps the project coherent over weeks and months. Claude and Claude Code are not the same thing, and they are not in competition. Claude, accessed through the web or the desktop application, is a conversational assistant. You give it ideas, plans, half-formed questions. It helps you think. Claude Code is a command-line tool that runs on your machine. It reads files in your repository, writes code, runs tests, invokes commands. The chat thinks with you. The command line acts on your behalf. Using one without the other leaves value on the table. Claude in the chat is where you reason. You describe what you want to build. You explore alternatives. You paste error messages. You ask for a review of a plan before committing to it. You use it to interrogate design decisions that Claude Code has proposed. Because Claude Code, left to itself, will sometimes produce a plausible plan that falls apart on closer inspection. The chat has no access to your file system, and that is a feature. It forces you to be explicit about what you are showing it. Claude Code is the agent that actually modifies your project. At startup, it reads a file called CLAUDE.md at the root of your repository. We will come back to this file. It is central. It proposes changes, writes code, runs tests, installs dependencies. You approve each action, or you configure it to proceed automatically within limits you set. Claude Code is powerful, and for that reason, it needs guardrails. Those guardrails live in the CLAUDE.md file and in the practices we describe next. Here's the loop we recommend. You express a need to Claude in the chat. Claude helps you refine it into a plan. You carry that plan to Claude Code, which implements it. Claude Code produces code, runs tests, and reports back to you. You bring the results, the questions, the surprises back to the chat, where you review with Claude what was done. You adjust, and the next iteration begins. The human you is always in the loop. Neither tool is meant to run unattended on work that matters. Start in the chat. Describe what you want to build, in plain language as if you were talking to a colleague. Do not try to be technical or precise at first. The goal is to get your intent on the table. Claude will ask clarifying questions. What language? What operating system? What constraints? Who will use it? What matters most? Answer honestly. If you do not know, say so. The quality of what follows depends on how well you agree, in this first exchange, on what you are actually trying to do. If you have never used Claude Code, ask Claude in the chat to walk you through installing it, configuring it, and running your first session. The exact commands differ by operating system. The PDF lists them. But do not skip the explanation of what each command does. The goal is not just to run the tool. It is to understand what it is doing, so that when something goes wrong, and it will, you know where to look. From this point on, you alternate. Claude in the chat helps you plan a block of work. You give the plan to Claude Code, which does the implementation. You come back to the chat to review what Claude Code produced, to catch mistakes, and to plan the next block. This back and forth is not overhead. It is the method. Each tool has blind spots the other compensates for. The chat sees your intent and the big picture. The command line sees your code and your tests. You are the bridge. First good practice, a specific folder layout. We recommend a parent directory, call it My Applications, or whatever fits your conventions, containing 3 subfolders per project. First, a folder with the application name, which holds the code and the tool itself. Second, a folder with the application name followed by Run, which holds concrete executions, real input data, real outputs. Third, a folder with the application name followed by Archive, which holds the project memory, starting discussions, block summaries, retrospectives. 3 folders, 3 purposes, no overlap. The reason for this separation is simple. These 3 things evolve on different timescales and have different sensitivity. The code changes often and lives under version control. The runs contain data that may be large, private, or confidential. They should never be committed. The archive is your project's long-term memory, valuable but separate. Mixing them is the most common structural mistake we see. Typically, the run output folder ends up inside the tool folder, gets committed by accident, and 6 months later, the repository is bloated with 10 gigabytes of generated files. Keep them apart from day one. Second good practice, before you write any real code, build a small concrete test example. A handful of inputs, expected outputs, end to end. If your project will process PDFs, your test case is a 2-page PDF and the text you expect to extract from it. If your project will generate reports from spreadsheets, it's one tiny spreadsheet and the exact report it should produce. You can build it yourself by hand, or let Claude Code help you in an initial guided phase, but do it before the real implementation starts. This small example becomes the anchor for everything that follows. It catches regressions. It documents intent. It gives Claude Code a concrete target to aim at. Without it, you are asking an agent to build something whose correctness has no definition. Third good practice. Every concrete execution of your tool happens inside the run folder, not inside the tool folder. Each run gets its own subfolder, a named workspace, with its own configuration file, its own input data, its own output directory. The tool folder stays clean. The run folder grows as you produce results. This separation means you can delete runs without affecting the tool, archive old runs, share a specific run with a colleague, or rerun an old configuration months later without confusion. Fourth good practice. Inside the archive folder, maintain a subfolder called Development History. This is where you accumulate, in order, a starting discussion document, capturing the initial exchange with Claude, a Block 0 document describing the design decisions before any code is written, and then one document per block of work completed. Block 1, block 2, and so on. These files are the project's memory across sessions. If you leave for a month and come back, or if a colleague joins, these documents plus the code are enough to resume work without loss. Fifth good practice: at the end of each block of work, stop. Do not let momentum carry you into the next one. Ask Claude, either in the chat or in Claude Code, to produce 2 documents. The first is a retrospective of the block you just finished. What was done? What decisions were made? What is still open? The second is a starter document for the next block, a short brief, whose structure is detailed in the PDF. The test of a good starter is simple. A fresh Claude Code session, reading nothing but this starter, should know what to do. This starter is the single most important artifact you will produce between sessions. Sixth good practice: treat the Claude chat discussion itself as an asset. Keep it open across the life of a block. Come back to it when something surprising happens. But a discussion can grow long, and long discussions get expensive and slow. 2 habits help. First, when the discussion gets long, ask Claude to compress it, to summarize what has been established so far. Second, when you need to leave the discussion, ask Claude to generate a restart document, capturing everything a new discussion would need to continue. Save it alongside the project archive. We now turn to the first of our 2 scenarios: building an application from scratch. This is the case where you have an idea, a need, a problem to solve, and no existing code to start from. The blank page is a specific situation with specific pitfalls. The main risk is rushing, getting excited about the tool's capability, letting it generate hundreds of lines in the first hour, and ending up with a codebase you do not actually understand. The method we describe in this section is designed to prevent exactly that. We will walk through 10 steps, from the first chat message to a validated first block of working code, with pauses and artifacts at each stage. You have a problem you want to solve with software. Perhaps it is automating a workflow you do by hand. Perhaps it is implementing an algorithm from a paper. Perhaps it is building a tool for your team. What you do not have is code. Maybe you have sketches on paper. Maybe you have nothing but a description in your head. The method we describe works in either case. What matters is that you are about to create a new project, and you want it to be well structured from the first commit. Open a new discussion with Claude. Describe the need, in prose, conversationally. Do not open with a technical specification. Open with intent. What problem you are trying to solve, who will use the result, what constraints you already know about. This first message sets the tone. A sentence or 2 of context is worth more than a wall of bullet points. The PDF lists the elements worth mentioning. Let Claude respond. You will usually get clarifying questions. Claude will ask about the tech stack, the environment, the constraints, the scope. The detailed categories are in the PDF. Answer each honestly, including "I don't know," when that is the truth. Do not guess. An unexamined guess at this stage becomes an assumption that propagates through the whole project. When a question is above your head, say so. Claude will help you decide. The goal of this exchange is not to impress the agent. It is to get everything important on the table before code begins. Once the clarifying exchange has settled, ask Claude to propose a high-level plan, a list of blocks of work, from block 1 to block N, with a short description of what each block produces. Read the plan critically. Does block 1 feel too big? Split it. Does the order make sense? Propose a different one. Is there a block whose value you do not understand? Ask why it is there. When the plan feels right, save it as block 0 in your archive folder. This document is the spine of the project. Everything that follows refers back to it. Now set up the folder layout we described earlier. The idea: 3 folders side by side, 1 for the tool, 1 for the runs, 1 for the archive, ready to welcome code, data, and memory on their separate tracks. The exact commands depend on your operating system. They are in the companion PDF. Running them takes 2 minutes, and saves hours of reorganization later. The point here is not the commands themselves, but the mindset they encode. Structure first, content second. Inside the application folder, the first commit sets the tone. 3 artifacts establish that tone: a version control history, a README describing the project in 1 page, and a CLAUDE.md file. Short at first, enriched over time. The CLAUDE.md is what Claude Code reads at every session. Think of it as the contract between you and the agent. At project start, it contains the essentials: the project goal, the technology stack, the coding conventions, the interaction rules. The PDF gives the detailed list of what to put in this first version. Before any real feature work, build a small, end-to-end test case. A minimal input, a minimal expected output, and a way to verify they match. If your project will eventually process PDFs, your test case is a 2-page PDF and a known reference output. If it will run numerical simulations, your test case is a configuration with analytically known results. Build it by hand or with Claude Code in a guided phase, but build it. Skipping this step is the second most common mistake we see. The project starts producing code fast, everyone is excited, and 3 weeks in, nobody can say whether the code is correct, because there is no definition of correct. This test case is the contract. Any code Claude Code writes afterwards must make it pass. The first Claude Code session has a specific shape. The agent must first absorb the context, the Claude.md file, the Block 0 document, the conventions you have established. Only then does it propose a detailed plan for Block 1, which files it intends to create, which tests it intends to write, in which order. Your job at this stage is to review that plan critically. If anything feels off, push back. The PDF lists the questions worth asking before approving. The principle: no implementation before a plan the user actually agrees with. Claude Code will implement Block 1 in a sequence of small steps. It writes a file, proposes a commit, runs the tests. You review each diff. You approve or you ask for changes. Here is the pitfall: do not batch approve a day's work. The temptation is real. The agent is fast. The commits look plausible. The green check marks are satisfying. But the discipline of reviewing each commit is what keeps the codebase yours, rather than a black box you trusted. If the tests pass and the diff looks right, commit. If the diff has an issue, an unnecessary abstraction, a questionable dependency, a misread of intent, say so, and Claude Code will revise. This is normal and expected. When Block 1 is complete, all tests pass, the feature works, the diff is committed. Do not start Block 2. Stop. 2 documents must be produced before anything else: a retrospective of what was just done, and a starter for what comes next. The PDF gives the exact naming convention and the structure of each. These 2 files are what turns a block into a closed chapter, rather than an open wound. Commit them into the development history. After closing a block in Claude Code, come back to the chat with Claude. Show it the retrospective. Ask for an outside look on what was just done, the kind of review a colleague would give you at a whiteboard. This review is where the discipline pays off. Claude in the chat has seen the whole conversation around the project. Claude Code has seen only the repository. Together they catch things neither would alone. Whatever emerges that matters for future sessions goes into the Claude.md. What we have just described is one full block cycle: plan, implement, test, retrospective, starter, review, update. Every block follows this same shape. Block 2 starts when you feed the Block 2 starter document to a fresh Claude Code session. And so on, Block 3, Block 4, all the way through. The cycle is boring, and that is the point. Boring cycles produce software you can trust. Exciting cycles produce software that surprises you in the worst way. 3 months later, a running discussion with Claude accumulates context. That is useful. Until it becomes too much. You will notice the symptoms. Responses slow down noticeably. Claude starts forgetting decisions made earlier. Answers drift from the point, and your usage limits show up faster than before. When you see these signs, usually after several blocks of work, ask Claude to compress the discussion. Give it a specific instruction. Summarize the key decisions, the open questions, and the current state, in a form that a new discussion could pick up. Review the summary. Save it. Then you have a choice. Continue in the same discussion, with the compressed context as a reset point, or start fresh. If you decide to leave the current discussion because it is too long, because you want a clean slate, or because you are stepping away for a while, do it properly. Ask Claude to generate a restart document, a self-contained file capturing everything a new discussion would need to resume. The PDF lists what it should include. Save it in your development history. When you come back, tomorrow, next week, or in 3 months, you open a new discussion, paste it in, and continue where you left off. To recap the from scratch method: 1. Describe the need in prose. 2. Answer the clarifying questions honestly. 3. Agree on a high-level plan, and save it as block 0. 4. Set up the 3-folder layout. 5. Initialize the repository with a short CLAUDE.md. 6. Build a small test case. 7. Start the first Claude code session and read the context. 8. Execute block 1 commit by commit. 9. Close block 1 with a retrospective and a starter for block 2. 10. Review in the chat. Then repeat for each block. No step is skippable. We now turn to the second scenario, which is in some ways harder. You are not starting from a blank page. You are starting from a codebase that already exists. It might be a script you wrote years ago and never cleaned up. It might be code in a language you want to leave, an older Python, a MATLAB file, a Visual Basic application. It might be a colleague's unfinished work, or a spreadsheet with macros that grew out of control. Whatever it is, you have source material, and that changes everything. The blank page discipline still applies, but now you must add 3 things: a policy for reading the existing code, a policy for deciding what to keep and what to change, and a strategy for validating that the new version reproduces what matters from the old. The steps that follow address exactly this. You have existing code. It may run or it may not. It may be well structured, or it may be a single long file. It embodies knowledge, sometimes years of tuning, sometimes a rare combination of expertise. Throwing it away would be wasteful. Mechanically translating it would carry forward its quirks and bugs. The method we propose is a port, a clean re-implementation that preserves the essential behavior, documents the decisions, and validates numerically against the original. Claude and Claude Code are well suited to this, because reading and explaining code is one of their strongest skills. Before you touch anything, move the existing code into a subfolder of your archive folder, named something like legacy version or original source. It becomes a read-only reference. You will consult it, you will quote it, you will validate against it, but you will not edit it. This separation is crucial. Editing the legacy muddies the reference. Committing the legacy to your new repository conflates 2 different histories. Keep the legacy preserved, untouched, in a place where you can find it but where it cannot be confused with new work. Open a discussion with Claude. The first exchange must cover 2 things: what the legacy is, and what the goal is. The PDF has the detailed checklist of facts worth establishing on each side. What matters at the level of principle is that your goal description must be specific enough to be actionable. Rewrite it in Python is too vague. Rewrite the statistical core in modern Python. Keep the same numerical conventions. Modernize the GUI is a specification. Claude can work with the latter. The former produces a port that drifts. Before you decide anything, read the code with Claude's help. The principle is simple. You cannot port what you do not understand. Claude can summarize functions in the language of the problem you are solving, rather than in generic programming jargon, and it can point out data flows, coupling, and suspicious corners you would miss alone. The PDF lists the categories of questions worth asking during this reading phase. It is slow and unglamorous work, but it is where you discover what the code actually is, as opposed to what you remembered it being. Every port that skips this phase regrets it. From the reading phase emerges a document, the block 0 equivalent for a port, capturing the design decisions you are about to make. It covers conventions, names, data structures, parts to rewrite cleanly versus parts to translate mechanically, and dependencies. The full list is in the PDF. What matters here is the role the document plays. It is long, explicit, and deeply useful. It is the contract you sign with yourself before coding begins. Every time a future question arises, why did we do it that way? The answer lives in this document. Without it, the port drifts, and the drift is invisible until late. In any non-trivial legacy codebase, you will find things that look wrong. A variable that should be a standard deviation but is coded as a variance. A missing bounds check. A formula that disagrees with the paper it cites. For each such finding, you face a choice. Is this a bug to be corrected? An intentional behavior you must reproduce? Or a harmless accident, whose fix would invalidate years of reference results? Getting this wrong is a serious pitfall. Silently correcting what you think is a bug can break validation against years of results. Silently preserving what is actually a bug carries the defect forward into the new code. Decide explicitly, document the decision, and, when you correct a bug, record the original behavior so the new version can reproduce both if needed. A port always faces conflicting conventions. The legacy language has its conventions. The target language has its own. The specification you are working from, a book, a paper, a written requirement, a user's expectation, has a third set. You cannot satisfy all three. Choose deliberately. Our general advice: when in doubt, follow the external specification over the legacy code. The specification is the shared vocabulary with future readers of your project. The legacy is an implementation detail. Convert at the import boundary, and document the conversion with a comment visible at that boundary. Ask the legacy to produce a set of known outputs on known inputs, small, controlled scenarios, whose results you can save as reference files. These become fixtures for your new version's tests. The test is not, does my new code compile? It is, does my new code reproduce, within a documented tolerance, the outputs of the legacy on this scenario? This is the same logic as the small test case in the from-scratch method, but now the reference is the legacy itself. If the legacy runs on a license-constrained tool, say, MATLAB, capture the fixtures when you have access, and use them offline for months afterward. Now you execute blocks the same way as in the from-scratch method, but each block closes with an extra step: a comparison of the new output against the legacy output on the same input. When the outputs match within the tolerance you have chosen, the block is done. When they do not, you investigate before moving on. This comparison is what distinguishes a port from a rewrite. It is also what protects you, months later, when someone asks whether the new code really reproduces the old one. You can show them the comparison. As the port progresses, enrich the CLAUDE.md with a mapping. For each important concept, function or file in the legacy, note its counterpart in the new code. This mapping is invaluable for two reasons. First, when Claude code works on a later block, it can look up the legacy reference for the concept it is implementing. Second, when you come back after a break, or when a new collaborator joins, the mapping is a Rosetta Stone between the two versions. Keep it updated. Stale mappings are worse than no mapping. To recap the port method: 1. Place the legacy in a read-only archive subfolder. 2. Describe the legacy and the goal to Claude. 3. Read the code together before deciding anything. 4. Produce a design decisions document. 5. Classify each finding as bug, behavior, or accident. 6. Choose conventions deliberately. Follow the theoretical reference when in doubt. 7. Build reference fixtures from the legacy. 8. Execute blocks validated both by unit tests and by numerical comparison. 9. Maintain a mapping in Claude.md between legacy and new. The from-scratch discipline applies throughout. These 9 steps are what you add. We have covered a lot of ground. 2 scenarios, many steps, 6 good practices, a handful of artifacts. Before we close, it is worth stepping back and asking what runs through all of this, what the common structure really is. It is not a matter of tools. Claude and Claude Code are impressive, but they are instruments. What matters is the discipline with which you use them, the artifacts you produce around them, and the honesty with which you review the output. In this final section, we distill the key takeaways, flag the pitfalls we see most often, and point to references you can use to go further. 4 things to take away. First, Claude and Claude Code are complementary. The chat for thinking, the command line for acting, and you are the bridge. Second, structure beats speed. A project with a Claude.md, a folder layout, and a development history will outrun a project without them, every time. Third, pauses between blocks are not friction, they are the mechanism that keeps the project yours. Fourth, write the restart documents before you need them. The starters, the retrospectives, the compressed summaries. They cost little in the moment and are priceless later. And 4 pitfalls to avoid. First, letting the agent run too fast, approving commits you have not read, trusting tests you have not verified exist. Second, skipping the small test case. Coding without a definition of correct is coding without a break. Third, mixing tool and runs in the same folder. Every project that does this eventually pays for it, usually when it is already too late. Fourth, treating the chat as disposable. A chat contains decisions you will want to revisit. Preserve the trail, or you will relitigate the same questions next month. A few references to go further. The official Claude documentation at docs.claude.com for the chat features and Claude Code installation. The Anthropic blog for the latest changes to the tools. And for CLAUDE.md in particular, the examples shared by the community on GitHub are an excellent source. Search for Claude.md on the platform and read a few real ones. There is no better way to learn the form than to read it. Thank you for watching, and good luck with your next project, whether it begins on a blank page or on top of something older you care about. A brief note before we part. Everything you just heard is a personal point of view, drawn from one person's practice, not an official position from Anthropic, and not a standard anyone has to follow. Claude and Claude Code are evolving tools, so the specifics may shift over time, even when the method holds. When a detail matters, it's worth checking the current documentation. Treat what we covered as a starting point, and above all, trust your own judgment. If a practice here helps you, use it. If it doesn't fit your situation, adapt it, or ignore it. One last thought, and it is the one I most want you to remember. Letting Claude Code work inside a folder on your computer is a real decision, closer than you might think to handing someone physical access to your workstation. Once the agent is running, it can read, create, modify, and delete files in the places you grant it. The chat deserves similar care. Anything you paste there leaves your control. Before you start a project, take a moment to ask yourself what actually lives in the folder you are about to open up. Credentials, private keys, confidential work, irreplaceable documents. None of these belong anywhere the agent can reach. Work from a dedicated, isolated project folder. Keep version control in place before anything non-trivial. And when in doubt, ask the simple question, would I be comfortable if this folder or this message were exposed? If the answer is no, stop, clean up first, and come back when the answer is yes. Thank you for watching.